Hey guys, Keith from Coolant, and today we're talking about our new Polyphoenix stills. These are an extremely exciting product we've got in the range now and just gone up on the website. Over the coming weeks, we're going to do a number of different videos showing how to do pot distillation, reflux distillation in a number of sort of video series which are going to add together on our YouTube channel, so look out for that. But the reason why we wanted to release these stills is essentially we wanted a still to be really modular, so people could add and decrease the number of parts they've got in the still, turn it into a reflux column or turn it into a pot still, or turn it into a still with a gin basket or something like that. And all of these accessories are now available on the website. So this video series is going to cover all of those different configurations on how you can set this up and how to get the most out of it. Now, some of you guys are going to be looking at these stills going, what the heck? This looks nothing like a still I've ever seen in the past. And that's because they've been completely redesigned from the ground up. Now, the first thing you'll notice is we use these injection molded components. So each one of these sections is injection molded out of a plastic, which is see-through, as you can see. And that's fantastic because it makes it really easy to see what's going on in the still. And when you're trying to learn about the hobby, I think being able to see the process and be able to visually see everything that's going on makes it really, really easy to use. The other thing is when you're using these injection molded components, it's easy for us to have a lot of areas where we can interface with the still. So unlike welding or copper fabrication or stainless steel fabrication, it's hard to get all the parts exactly precise in every different angle and area because they're not exactly machined. Generally, these stills are welded up if they're made out of copper or stainless. So for us to make a whole lot of accessories, things like shotgun condensers, for instance, they can bolt onto the side of the still, and we know the hole placement is exactly the same on all the different segments that come out of the injection mold. Similarly, with all the things like the condensers, the product condensers here, or these silicon parts here, or even the gin baskets or the bubble capper plates, they're all made to be a very precise fit, and they fit together because these products come out of an injection mold. The other thing is the PPSU plastic has been an amazing plastic. We've already started to use PPSU because of its amazing heat resistance. It can go up to over 200 degrees Celsius. It can also handle a wide range of chemicals. So using caustic or acid cleaners or stuff like that, it'll be perfectly fine. The other thing is, the PPSU doesn't contain plasticizers which can leach into the beverage itself, and that's not just the case with water, but also in particular in this application, solvents, so things like ethanol or even some other solvents that you might be distilling in the still as well. So the wide range of chemical compatibility, the high temperature rating, the robustness of the plastic is the reason why I've started to use PPSU in a lot of these distillation segments. So I know there's going to be some hillbillies out there going, oh my God, you can't use plastic in a still, but there's going to be enough customers out there who come from a science background and understand that this is something that works really well, and it takes advantage of some of these new amazing engineering plastics that are available to us. Now, I shouldn't say that these plastics are cheap at all. Like, for us to make a straight stainless steel section would actually be cheaper than us making these segments out of stainless steel. But what makes it a lot better than stainless in our opinion is also the fact that these have much, much better insulation. So when you're looking at a still, one thing you're trying to create is a stability across the process. So the last thing you want is temperature fluctuation and temperature changing. And one of the things that can do that is if you've got an ambient room or area or outdoor area for that matter, and let's say you've got a gust of wind or something that comes through, let's say you've got these bubble capper plates all perfectly loaded. If you get a change in ambient conditions like wind blowing through, that can cool the column down and start to make your bubble capper plates collapse down back into the boiler. If it gets too hot, the other thing will happen and things like your tails will start coming through into your end product. So stability is absolutely key, irrespective of whether you're doing reflux distillation or you're doing bubble capper or pot distillation. And that is really important. And naturally, the plastics like PPSU are insulative inherently. So if you get a PPSU plastic like a segment like this, if we compared that to stainless steel, it's roughly 20 times more insulative than stainless steel. So automatically, straight off the bat, you've got the ability to see what's going on. You've got better insulation than you would with copper or stainless steel. And then you've got really fantastic, resistance to a wide range of chemicals. And then lastly, you've got this, ability to have an interface with so many different parts. So from our perspective, the PPSU plastic made just so much sense. And we can't believe that other people haven't made stills like this out of plastic in the past. Now, if you've been distilling for a while, you'll know that there's three main types of management systems which you can use to control the flow of spirit, to basically control what stays in the column and what comes out. Now, those three management techniques are coolant management, flow management, and vapor management. So those three management techniques are used throughout all of distillation in a lot of different builds, and a lot of people integrate, two different methods or three different methods throughout the distillation run. So if you look at something like our alco engine stills, for instance, that are on the website, been selling for a number of years now, that uses flow management. Really easy. You basically open the liquid output, and it's got a little device in there which restricts the flow, and that controls the speed of the flow of the liquid spirit coming out of the columns. That's a flow management technique. If you've got another one, let's say coolant management. So what you can do is adjust the coolant flow, for instance, inside a cooling coil, and basically the amount you adjust the coolant flow will essentially affect the ratio of what turns down back into the column and what comes out of the still. Now, I'm not a massive fan of a lot of coolant management products, to be honest with you, because I feel like it's a very delayed reaction. If you change the coolant flow, it takes quite a while sometimes for the temperatures to stabilize after you do that. But there's another one which is vapor management. This is one which I think is really underutilized for a lot of home distillers at the moment. But vapor management is a fantastic way for you to take vapor out of a distillation column. And when you do that, you end up with a very stable column, because when you take vapor, it doesn't have the mass that liquid does when you're taking it out of the column. So in our opinion, we want to design this particular collection unit here, and this particular part of the still is central to a lot of the designs that you'll see in the Polyphoenix, because it enables us to use both flow management and vapor management on this collector unit. So let me show you inside this and show you how it works. As you start to use the Polyphoenix unit, you'll start to appreciate how amazingly flexible this modular design is. So for instance, I've got all these parts here, which is set up. So I've got a reflux column typically. So this is for making vodka. I was just doing some vodka the other day. I've got my spiral prismatic packing here, and then I've got the collector unit here, and then I've also got my product condenser on the top. Now with that said, this product condenser is mounted in, for instance, a horizontal orientation, but I could just as easily make it vertical if you really wanted to and put it like that. But look, I kind of like this sort of hammerhead shape. It also means that it reduces the overall height, and I'm not particularly tall, so reaching these valves and stuff like that's a bit easier. But anyway, that's that setup, but I could also use these same parts to do a different setup. So like here's like, for instance, a CCVM setup that I got over here. So it's how I was doing whiskey. I could do something like that, for instance. Now, there's a few central parts to how this type of still works. You'll notice that we've got all these 1/2-inch threads here, and these silicon quick swivel connector and stainless parts here. So this can come off any of the segments of the still, making it really easy to interface with. So let's say I wanted to put a thermometer in, I just use this bung here, which is designed specifically for this job. And this profile of the bung fits, the majority of our different thermometers that we sell, put it in the side. Let's say I wanted to attach something else. So I wanted to attach a ball valve or, some other stainless part. These threads are all 1/2-inch, making them really compatible with lots of other stainless 1/2-inch fittings if you want to put something else in there. I should also say these quick swivel connectors are kind of nice to use in the sense that they've got silicon on the outside. So even when the still's running at full temperature, these are cool to touch. So you can just grab these and undo them or do them up or whatever, and you'll be fine. There's a large range of different accessories we've got with the quick swivels as well. We've got more and more of them coming out, both for the brewery equipment, but also for the distillation stuff too. So you can see, for instance, on the output here, I've got the quick swivels on the shotgun. So I've got an elbow here, which goes to a duo type barb. And then I've got, for instance, a larger 13mm barb on there as well on the top of the shotgun. So the central part to these stills is this sort of skeleton funnel here and collector unit. Now, the beauty about this type of unit is it can be used for many different configurations, irrespective of what type of distillation you're doing. So if you look at, for instance, something like the T500 still, that's a coolant management design. So you've only got coolant which is used to basically control the flow of liquid out of the still, and basically determine what percentage of spirit turns back down the column. There's other methods as well. I mean, there's three main methods of distillation management. There's liquid management, vapor management, and coolant management. Look, I'm going to put aside power management and the combination of multiple managements together, like CCVM and stuff like that, for instance. But with respect to most distillation, they'll fit into one of those three categories. And the problem is a lot of the smaller hobby stills, they'll only give you access to one method. So even with our alco engine still that we sell, that's a liquid management. So you can control a liquid coming out of the still at a certain rate, but you don't really have any more access to change the collection ratio or the turn down ratio beyond that. So the beauty about this type of setup is it gives you a lot of flexibility, and even halfway through a run, you can switch from one management method to another. So let me give you an example of where this would be ideal. So I've got this vodka column set up here, let's say. I'm making a pure neutral spirit. And if you look at the parts that are inside the still here, I've got this collector funnel. So as you can imagine, vapor's coming up the column here. And because of these large holes and stuff like that through this skeleton funnel, the vapor can easily come through here and hit that product condenser that I had on the top here a moment ago. But what I've got is the ability to capture liquid, which falls into this funnel, and the liquid is directed down this output here, and then also falls into this tray. So what I have is basically two outputs on this collector plate, giving me the ability to do both the liquid management via this valve here, and then also I can do vapor management via this valve here. So if you have a look in here, for instance, you can see that hole just there. That's my vapor management hole, so it comes out this bigger barb. Obviously the barb needs to be bigger because vapor is more voluminous. And then the tray here basically collects that liquid, and then it comes out this barb here. So if I was doing a vodka run, by far one of the easiest ways to separate the heads when you're doing a vodka run is by using this liquid management. So what I would do is start with both of these valves closed on a vodka run. So you can just pretend that's all the way closed. And then this one is all the way closed. Then what I would do is once the still starts to stabilize, I would open this valve slightly and just use liquid management. Now, technically what I could do is use liquid management throughout the entire distillation process and just use that. That would be just like, for instance, the alco engine still. However, one of the problems with vapor management is it's not as stable. One of the problems with liquid management is it's not as stable as vapor management. So if you look at vapor management, for instance, one of the beauties and one of the reasons why it's so stable and perfect for making a really pure neutral vodka or something like that is because it gives you exact control over the ratio of what comes out of the still and what goes back down onto the packing. So what I mean by that is, let's say I've got a change in power. So the power on the grid changes up and down, throughout the day, depending on the demand on the grid. So the voltage will go up and down, I should say. So, based on that, if you have less vapor come up here because the power is fluctuating or changing, then also, the ratio of what comes out this hole and what goes onto the on top of the condenser and then flows back down the column will be the same. So that reflux ratio will always be the same, making it very, very stable in terms of the whole process. However, if I use liquid management, for instance, let's say I open this valve, I'm collecting at a very constant rate, and I've got, let's say, 5 mils per minute or something that I'm collecting out of this coolant, this liquid management collection. Irrespective of the power change, the liquid is kept constant. So what happens is I end up with a much less stable process because the reflux ratio will be changing throughout that distillation run. Similarly, the amount of vapor coming up the column will change varying on how much alcohol you have left in the boiler, for instance, and stuff like that. So look, the ideal scenario would be, take your heads off with liquid management, open that up, then close it up, and then, after you've done that, do the bulk of the collection run using vapor management. So that flexibility to switch between one management method and another halfway through a distillation run simply doesn't exist with a lot of other still designs. That's one of the things that I find really nice about this. Let's say I've got, a still design like this. There's multiple ways I could, use this type of still. So for instance, I could lift up or reduce the height of this and use the same parts that I've got here. So you can see I've got that same collection plate, the same product condenser, but this time I'm using it in a CCVM setup. So I've basically got the ability to pull this up and down, and that will basically control the amount of vapor which escapes here and the amount that goes back down into the column. Another great way to do it. Another thing I could do is just vary the coolant flow through the top here, and that would also basically affect the ratio of what comes out here or goes down this way. So as you can see, super flexible, lots of different things you can do with the Polyphoenix, irrespective of your pot distillation, doing pot distillation or whiskey or gin or whether you're doing vodka, the same parts will do you for various different applications. Another critical part of a lot of our still designs is this shotgun condenser. So one of the important parts of the shotgun is to basically cool the flow of liquid out of the still. So a lot of the hobby stills, like the smaller Alco engines we have, or even some of the stills that you might buy, like the T500 or some of the other stills, essentially what it does is condense the spirit with something like this. So it condenses that product, and then it comes out of the still head still hot. Now, one of the problems when spirit comes out of the head of the still too hot is you lose a lot to evaporation. So what I'll have is spirit coming out of here, will drop into a collection container, and if that is over 40 or 50 degrees or 60 degrees Celsius, essentially you can lose anywhere between 5 to 30% of spirit just to atmosphere, as the evaporation through a long run can just sort of deplete your, increase the amount of losses that you're going to get. So a shotgun is really important. Now, if you look at a shotgun like this particular shotgun can absorb around about 4 kilowatts worth of heat, which is ideal because this column is kind of like ideally sort of designed to suit that type of shotgun. The other thing about this shotgun is we've got 2 inputs on it. As I was saying before, we've got the ability to do vapor management and liquid management. There's no reason not to pass both products back through the shotgun, which is why we have these 2 inputs on the shotgun. So if it's vapor, obviously we need to condense that vapor, into liquid. And then with the liquid flow, we want to cool that as much as we possibly can before we put it into a collection container. The other thing I should say is you've got to make sure that you're plumbing your shotgun up correctly. It should always be in a counterflow situation. So obviously the spirit and vapor is all entering from the top here and flowing down. So naturally you'd want your water to flow in through the bottom and up through and out the top. So you can even also plumb this, so after you go through the shotgun condenser, you can then go through your product condenser on the top of the column like this. Now you can have separate water supplies coming into this and this, but it's just as easy to control the flow through this and then go through the product condenser on the top of the column. So after you come out of this shotgun condenser, it comes down to this distillation parrot design. So we've tried to make this distillation parrot just as modular as all the other different parts of the still. So firstly, I should say, you've got these wing nut and bolts, which basically enable you to kind of like take apart and put together different accessories on the still with kind of like a Meccano type of experience. So they come with like a wing bolt and a wing nut like that, and they screw together to attach these accessories to the still. So you can have, for instance, this parrot connected rigidly to the body of the still like this, or you can use things like these tri-clover connectors to basically detach that part of the distillation parrot. And usually the distillation parrot's also sold with this stand, so you can use those same wing nuts and bolts to basically connect the stand onto the distillation parrot like this. Or you can, let's say you've got these slightly more bulky duo-tight valves on here, you can eventually adjust the height and make the stand a little bit taller. That way, if this is sitting on the bench, let's say you've got some flexible tubing coming out of here into the top of the distillation parrot, you can basically adjust the height like so, and that way you've got enough space to basically either open this duo-tight ball valve to drain the distillation parrot and basically clear it of any liquid, or the other thing you can do is unscrew the quick swivel connector like this and then remove that altogether and therefore empty the the distillation parrot that way. So it's really, really easy, really modular. We've tried to pre-think all the problems that people have with distillation. We've also put a little spring in here. So let's say I've got this glass alchemimeter in here. If I drop that in there like that, notice how it bounces up and down. That's because it's got a spring in there, so it doesn't just smash on the bottom of the distillation parrot. So other handy accessories are things like this stainless little shelf. Obviously, once again, attaches to the still column itself like that. So let's say I've got a jar. Instead of trying to get this hose to go off to a bench, I can leave my whole brewzilla, on caster wheels like this, and then, have a collection container which just sits on a shelf like that. Now, there's other accessories, as I was saying, things like gin baskets. So what I can do is, irrespective of which one of these, whether I've got a straight piece or a T-piece like that, the gin basket fits in both of these. So I can just basically drop that in there, or let's say take it out of there, and then I can put that into the straight section as well. So these are really handy accessories. Now obviously you could use multiple different gin baskets. I can bank up a few of these together, so one on top of each other like this, and then have a gin basket in each one. Let's say I've got a lot of botanicals, might have 2 or 3 gin baskets, for instance, but it is extremely modular in its design, allowing you to pretty much, go with any configuration you want. So some of you guys are asking, why did we choose the 3-inch size column? So the 3-inch size column really kind of made the most amount of sense for us, because that's how much power a lot of people have available. You see, if you're in your standard domestic household situation, you can draw easily between 10 or up to 15 amps, quite commonly in that range. And if you've got somewhere between 220, 230 or 240 volts, so if you're in Australia, or in parts of Europe, for instance, or many other parts of the world, you can essentially pull somewhere around about 3 kilowatts through a 15 amp power line. So we wanted to make sure that people had a still which could handle that maximum amount of power that they could easily deliver to the still head. Now, that also matches up really well with the different digiboils and brewzillas that we sell. So if you've got the 35 or the 65 litre digiboil or brewzilla, you can crank them up to max power, and these 3-inch columns will be able to handle it perfectly. If you've got 100 litre brewzilla, so our largest size, you will have to turn the power down slightly to run the column. You might be able to get away with it depending on the type of packing you've got. So if you've got the largest size spiral prismatic packing, I should say the spiral prismatic packing is an awesome packing for doing reflux distillation runs. You should definitely upgrade to that if you haven't done that already in your still. But if you're using the larger one, the 100 litre will probably handle it at full power. But if you drop down to the smaller size, a little bit more restriction, because you've just got more surface area on those small bits of spiral prismatic packing. But either way, we felt that this 3-inch size was perfect. If you drop down to the 2-inch, a lot of common distillation columns, which a lot of home distillers get into, are the 2-inch size. One of the problems with that is really they're only optimum size for round about 1.5 or 1 to 2 kilowatts, somewhere in that range. And really, once you go above that 2 kilowatt, you start to run into some flooding issues sometimes. So it can be a bit complicated. Even things like bubble cappers become a lot more difficult to manage with that tighter circumference you got to deal with. Now, of course, if you want to hear about any other Polyphoenix videos, definitely hit subscribe now, bottom right-hand corner, and make sure to hit that notification bell so you get notified when new videos land. I have to also give special thanks to Pavel, who helped us come up with some of the ideas of this, like the horizontal product condenser, for instance, as the Thor hammer still. He's been really helpful. I've sent the odd question to him here and there, and he's a very, very talented Russian distiller who's been making vodka and other stuff for many years now. So if you want to check out his YouTube channel, I'm going to put a link in the description below. He's also got his own software platform for managing the distillation process as well, so you can automate things like, controlling the flow of vapor out of the column and that type of stuff. He's got a lot of really, really cool stuff that he's done on his software. Anyway, that is it. If you want to be in touch with all the gear that's coming out, also sign up to our Facebook Homebrew community group. So that's an area where lots of guys like yourself, or thousands of them in fact, are sharing tips and tricks on how to get the most out of the gear. So go to Facebook, search Kegland Homebrew community group and join that one as well. All right, that's it, and hope to see you guys next time. Bye.